Okay, so today we will do the lab series AC circuit. Okay, the circuit is not difficult. So circuit is this one. Okay, so this is the formula we will use. Okay, so for series RLC circuit, so E square equals VR square plus VL minus VC square. Okay. So then E equals square root of the VR square plus VL minus VC square. Okay. So for this one, we can measure this, okay, VR, VL, VC in Tinkercad actually, okay, and then verify this, okay. For the amplitude, okay, so we know Z square equals R square plus XT square. Then xt, so this equals xl minus xc. So for this one, so actually we know this from the impedance, right? Hmm? Not working. So for the impedance, so we know CR, okay, let me still do this. Okay, okay. Oh, still need the map. Okay. So CR, this is the vector, right? So R 0 degree, GL, XL, positive 90 degree, GC, XC minus 90 degree, negative 90 degree. Okay, so we know CL and GC always on the same line, just in the opposite direction, right? So then we can get this. Yeah. So XT equals XL minus XC. This is also similar. So for the VL and VC, when we do homework, draw the pacer form. So we know VL, VC always on the same line, also in the opposite direction. So we can do this VL minus VC. Okay. And oh, I forgot one thing. So for the XL reactance of the inductor, so we know equals 2 pi FL. Okay. F is the frequency, L inductance. XC equals 1 over 2 pi FC. C is the capacitance. You will use these equations in the lab. Okay. Okay, so this is the circuit. Circuit not difficult. Okay, so resistor 1 kilo ohm, inductor 10 millihenry, capacitor 0.01 mu F connected in series. Then the power, so 10 kilohertz, and the voltage is the 8 volt, peak to peak value. This is important. So this is peak to peak value, not the RMS value or the magnitude like this one. This is the peak to peak value. Okay, so let me just yeah. So do this in Tinkercad. So create a new design. Okay, change the name first. Okay, so close this. So we need just the small brackets, and we need the power the function generator. Okay. Okay, so I can zoom in now. So this one is the 10 kilohertz. So I just need 10 here. The amplitude for here, you think cat amplitude is just the peak to peak value. So we can change this to 8. Then offset should be 0. Sine wave, so choose sine. Okay. Do you make this bigger? Yep. Okay, so then we just need these 3 components. Okay, resistor first. Oh, I forgot one thing, so I can, yeah, put here, resistor. Okay, so connect power to the breadboard. So positive. So this is red. Then positive to positive. The last is negative. Okay, then oops, this one change it to negative. So negative to negative. Okay, change this back to red. Okay, so this is the power. So now power line. So power line are connected. So power line on top and in the bottom are connected. So positive to positive, negative to negative. Then resistor 1.007, just change a little bit. Okay. Then inductor. Okay, so this is inductor. So it's 10 millihenry. So milli. Then this one. Okay, maybe let me rotate this. Okay, and this is has the direction negative. Okay, okay. So now I connect these 3 components in series. The next connect to the power. So this is the negative already in the red. So connect positive first. So positive. So this is the positive. Then this is the negative connect to the ground. Okay, change to black. Okay. Then the last one, so we need to measure the voltage across each component. So VC, VL, and VR. So for the real lab, we can only measure the one component at one time. This is we said before. It's because for the oscilloscope, this the black wire, this already connected to the ground. So this means when you measure a component, you should put the component in this position. The one need connect to the ground. If you want to measure the inductor or resistor, you need to switch position. So this means put the inductor in this position and put the capacitor to the original the inductor's position. Okay, so only in this position can measure voltage. Okay, in the real lab. So it's here. Yes. So make sure the element is placed in the position of the capacitor C. Okay, so you need to reverse the order of the elements so that the element across which voltage is to be measured. has the position of the capacitor here. Okay. But in tic-tac, we did before. For tic-tac, we know this is simulation. So actually, we could use the several the oscilloscope measure the voltage. Okay. This only in simulation we can do this. So we could use 3 oscilloscope now. Okay, so first one, so measure capacitor. So positive. Let me change it to red. So this is positive, another positive inductor. This positive so goes to resistor. Then okay, then change it to black. So active. So the left, this one across the resistor. Okay. So across resistor. So this is the VR. Then middle one, middle scope measure inductor. Okay, voltage. Then the last one, this oscilloscope, so measure the voltage across the capacitor. Yeah, it's fixed. Okay, so now actually we can run. Let me check. Run the simulation. Nothing is weird. So let me check. Oh, I did wrong. This one, so this one you can see I connect to the positive power. This is a like 10 kilohertz, still nothing. Yeah, this is correct. Let me check why the other place. Oh, this one I didn't change. Oh, this one I didn't change number. So 0.01 UF. Let me double check whether they are connected or not. This one, yeah, they are connected. Okay, let me use this way. So then here, negative, so positive, yeah, positive, positive, negative, negative, yes, then positive. Seems everything correct, but not okay. This one broken again. Okay, so maybe I need to use the disk one. Okay. Okay, delete this. Okay, rotate. So for the disk capacitor doesn't has any direction. Okay, so then we need a line. Okay, connect this. And the number, so mu 0.01. Okay, run simulation again. Still show nothing. Okay, so first let me check the power. Move this, go to the ground. Ground? Why? Even this way doesn't show anything. The left one should show the curve. Let me check whether this one. Let me reconnect this. So negative, positive. Okay, positive to resistor, inductor capacitor, then back to the negative. Yeah, everything seems correct. Okay, so it's so weird. So show nothing here. Negative. What? Yes, negative connect to the negative. Positive connect to the part. Oh, okay. Seems because the Tinkercad has some issue. Okay. Why shows the square wave? Okay, I think because the Tinkercad. Okay, so just a moment. Hmm. Let me try another browser. Okay. I already saved this one. Yeah, this is the latest one. It's the same. So I think this because maybe the Tinkercad, the website has some issue. Maybe, yeah, you can just try start this lab and try it now. Okay. So for this one, circuit seems correct. Yeah. So after build this in the Tinkercad, okay, then you need to measure this. So VR, VL, VC, this is from the measurement, right? Then I peak to peak, this is from the calculation. Actually, this no, this is use the measured value, then do calculation. So we know you could use this one, get the GT first, the total impedance. So GT, so we know equal GT square equals R square plus XT square, right? Then XT, so equals XL minus XC. So you can get the Z. This is the GT. Then E divided by GT, so we know is the R. This is the one way. Another way, so we already get the VR, right? So VR divided by R also is the R. You can use either way, okay? This is the series circuit, right? So this is currents are the same. So you could either way get the I peak to peak. Then GT VAB. Oh, VAB is the voltage between point A and the ground. So B is connected to the ground. So VAB actually is the voltage across the inductor and the capacitor. So for the Tinkercad, let me move this back to the resistor. Okay, so you could use the middle oscilloscope, then move the negative go to ground. Then this is the voltage across the inductor and the capacitor. Okay, so it's this one. Then calculation, so everything from the calculation. Okay, so you need like I said before. So this one you need to get the GT first, then get the I, next get the current, then use Ohm's law, I times R, so that's the VR, I times XL, so BL, I times XC, so that's the BC. Then compare these two set numbers. Okay, they should be very close. Okay, yeah. So this set, so IPP equals VRPP divided by R measured value. So we use this the right number. Okay, so just following this step by step. So lab is circuit is not difficult, just a lot of the calculations. Okay. Okay, so now, yeah, you can just the start now. Start this. Okay. So I will check. I think the issue because ticker cut. Okay, so the setting for oscilloscope is the 20 millisecond per division. So 20, just change this to 20, so show the curves. Okay. Then you need to get peak to peak value for AV component. Okay. So just for example, this one, so we know is 1, 2, 3, 4, 5, 6. Almost 6, right? So not exact 6. So you can think about it is maybe 5.8 divisions. So this is for VR, right? So VR equals 5.8 division, then times the setting. This is the 10 volt from top to the bottom. So we know total is the 10 divisions. So this means for each division is the 1 volt. So that's the 1 volt per division. So then VR equals the 5.8 volt. Okay. So then you can get others. Just check the setting for the voltage. Okay. Then get the voltage setting for each oscilloscope.